Hi class, so this is going to be the homework helper number 1 for the very first homework. This will be the 5th time that I've attempted to do this, so hopefully it works this time. For number 1, to fill in the chart, to create the sets of real numbers, okay, so we either have it in set notation, which is given here, or we have it in this interval notation, or we have this region on the number line, and so it all depends on what we're doing with that. And so, for example, on this first one, it says x is between -1 and +5. What does that look like in interval? What does that look like in the number line? So generally, it's always easier if we want to draw that first. So let's draw it. We know that it's included at -1 and it's excluded at 5. So if I wanted to draw that out, it's included at -1 and it's excluded, so an open circle at 5. And so there, for the interval notation, that's just going to be from -1 all the way to +5. If I wanted to do this one right here, I already know that it's from -infinity to 9. And so if I wanted to draw that out, I know it's going to be from -infinity all the way to 9, which is going to be an excluded value. And then to draw the set notation of that, x such that x is going to be less than 9. Now if you guys drew it like that, that's also correct. So both of those methods would be right. Now 2 through 7, it says in the exercise, find the indicated intersection or union and simplify if possible. So number 2, we know that we have -1 to 5, or the intersection -1 to 5 and 0 to 8. So drawing that out is always easiest to try and find the union or intersection. So let's draw that out. We have first the -1 to 5. So here's our number line. Let's say that's -1. It's an open circle, and it's going to go all the way to 5, which is now a closed circle. And then we have 0, which is a closed circle. Actually, let me shade that first. And then we have 0, which is a closed circle, all the way to 8, which is going to be an open circle. And so that's going to get shaded. So because it says intersection, intersection is what they have in common. What is the same in both, or where do they overlap? And so this region right here is where they overlap. And so I can say that my intersection is going to be from 0 all the way to 5. And so that's going to be my answer. Let's do number 3. On number 3, it says the union of -1 to 1. So let's draw that out. So we have -1 to +1, open circle, shade in between. And then also we have a bracket from 0 to 6. So here's 0, and then closed circle from there all the way to, say this is 6. Closed circle there, and so we have that region there, and so it's both combined together. So if I were to imagine this being combined, it would be from -1 all the way to 6, and so that does have an open circle. So this is going to be from -1 all the way to 6, which has a bracket. Okay, so let's look at another one. Number 10. Number 10 here, it says x such that x cannot be -3 or 4. So on our number line, we said that x can't be -3, x can't be +4, and so it's going to be everything in between. And so writing the interval notation of that, it's going to be x is from -infinity all the way to -3, union from -3 to 4, union from 4 all the way to +infinity. If I did number 18, it says x is greater than 2 or x is plus or minus 1. So on my number line, we have -1, we have +1. It says it is that, so they're closed circle, they're included. And then also x is greater than -2, or x is greater than 2. So that's open circle, and that's all shaded. So I can say that this is -1, union, positive 1, union, and then from 2 all the way to infinity. Now this is supposed to be a parenthesis because it's an excluded value. Got carried away with all those brackets in the previous one. All right, so let's look at the next one. Number 20, it says plot and label the points. Well, I'm going to let you guys, I'm confident that you guys know how to plot points, and it's going to be kind of combined with this one anyways, which is 21, which asks us identify the quadrant or the axis, find the point symmetric to the x, find the point symmetric to the y, and then find the point symmetric about the origin. So let's look at A. Let's examine point A. So if I were to draw that, point A is going to be -3, -7. 3, 4, 5, 6, 7. So that's point A. So it says identify the quadrant that it's in. So the first bullet point, it's in quadrant number 3. It says find the point symmetric about the y-axis. Okay, so being symmetric about the y-axis, so if this right here is my, or sorry, it says about the x-axis. So if this is my axis point here, so it's being flipped over that axis there. So the only thing that's changing when it's getting flipped is the y values. So y is going to go to -y. So all I need to do is just basically, if my point is -3, -7, I'm adding a negative to my y. So that's going to be -3, +7. Then it says find the point symmetric to the point about the y-axis. Okay, so if I'm going to find the point about the y-axis, then examining this, okay, here's my y-axis here, it's changing, the x is changing, okay, the y is staying the same, so my x is going to -x, and so that's going to be +3, -7, and then the last bullet point says about the origin, which just means you add a negative to both, and so that's going to be 3, +7. For problems 22 through 29, find the distance d between the points and the midpoint m. Okay, these are straight from the lesson. I'm just going to say go back to the lesson, review the lesson, and look at that. And this is lesson 1-3, but the examples are pretty much identical. They're the same thing. Same thing with 30 through 33 when it's a distance of X amount of units from a given point. Okay, those are identical, so go ahead and go and take a look back at those. Let's talk about 37. 37 is a good one. Now on problem number 37, it says show that points A, B, and C below are the vertices of a right triangle. Okay, so that's really important there, that phrasing right triangle. If I have a right triangle, what that means is that the Pythagorean theorem is true. The sum of the two legs squared equals the hypotenuse squared. And I can make the assumption that C is the largest value. So I know this one's going to take a little bit more work, but what I should do here is let's plot them. Let's visualize this. Point A is -3, +2. B is -6, +4. So it's 4, 5, 6. 1, 2, 3, 4. And then C is 1, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so you get this here. Now I know because I didn't draw it evenly to scale, it's kind of hard to see is the right angle here or there, but that's okay. You'll be able to find that eventually. And so because to be able to do this, I have to know what A is. Well, to find A, I have to find the distance. And so you're going to find the distance between these values here. And then once you find the distance using the distance formula that we previously talked about, then I can plug them into the formula. And you just need to make sure that your C is going to be the largest one of these distances. So let's say if you found D2, that was your largest distance, that's going to be your C. And so that means D3 and D1 are going to be your A and B when you plug it into the Pythagorean theorem. And all you need to do is just verify it. If you verify that that Pythagorean theorem is true, then you have officially shown that it is a right triangle. If you have any other questions, please leave them in the comments.